Now we're going to talk about functions. By now, you must have been dealing already about numbers, the x's, the y's, even the z's. This time, the topic of function will allow us to visualize things, so we can interpret problems better and be able to plot them as points, lines, and even graphs. So what are functions? Functions can be thought of as like machines. You have an input and an output. So if you say we have, for example, a factory of for wood, we have here the logs. And by means of this function, or a wood factory, the logs that we place into the machine comes out now as various food products. Like, for example, tables, chairs, or even planks for houses. That is an example of a function. Let's take another example. Functions could also be thought as simple as, say, a blender. This is a common thing you find at home. If we say the input is apples and another input is ice, what do you suppose that we come up with? We come up with an apple shake. So this is an example of an input. This is an example of an output. If we replace this fruit with, say, a mango, of course, we wouldn't be coming up with an apple shake. This will now be a mango shake. How is this now related to math? For your past meetings in math, you must have been encountering so many y is equal to some things. Y is equal to 2x, y is equal to 3x, y is equal to, for example, a longer equation, 2x squared plus 3x plus 1, or more complicated ones, y is equal to 5x over 2x minus 3. All of these are equations. And all of these equations can be interpreted as f of x. So now the y that we've been so used to at could be interpreted as an f of x. This is called an f of x, meaning this function, you will have an input, that is the x, and you will have an output, and that is what you call the y. So this is what you call a function. So let's take, for example, this equation. Y is equal to 3x plus 1. This function can now be interpreted as no longer y, but also an f of x. There. Then your books or your teachers could also be showing you other ways by which a function could be represented. This is one example of a functional notation. So our equation, y is equal to 3x plus 1, can be interpreted as f of x is equal to 3x plus 1. This can also be interpreted as x mapped as 3x plus 1, or another notation such as f of x, where x is mapped as 3x plus 1. More traditional mathematical examples prefer a longer algorithm, such as f is a function of x and y, such that y is equal to 3x plus 1. So given these two examples, y is equal to 3x plus 1, f of x is equal to 3x plus 1, one cannot help but ask, how can we distinguish now if an equation is a function. There is a huge difference. An equation is normally denoted by the equal sign. So it can be anything that has or involves an equal sign. It can be an x is equal to 1, x squared is equal to 5x. It can be 0 is equal to y, anything with an equal sign. How can we distinguish this now with a function? Let's represent these two things as Venn diagrams. So the left circle here, we can call this the set of equations. This right Venn here can be called as the set of functions. So a function, if we may go back, is any equation that has an input and you have an expected output. So that can be like our example earlier. 3x plus 1, x is our input, so we come up with a value, a y. The inputs are not restricted to just one variable. They can be consisting of 3 variables. For example, 1x, you have 2 y's, 3 z's, to give you an m. So in this case, your variables or your inputs are x, y, and z, and your output is m. Which brings us now, are there equations that are not functions? Yes, there are. Because if we're not sure about the output, that could be a probable equation, a function. So for example, if we give you like a 0 is equal to x squared plus x plus 3, we may have a variable, but we don't have an output. Because in this case, the output is just always 0. How about this one? This is a more complicated math, but with this example, there are no unique values for any one of these. Remember, if you have an x squared, you have a possibility of having a negative or a positive value. So these are examples of equations that are not functions. How about this part? This part here denotes the set of functions that are not equations. Functions could be interpreted not just this form. They can also be in the form of tables. So for example, an example of a table is when you get to a highway or a toll gate. These are the exits. These are your corresponding prices. You may have exited at, say, kilometer 5, kilometer 15, and kilometer 20. You will have corresponding rates. For example, 10 pesos, you have 30 pesos, and you have 50 pesos. This is a fairly simple function, which means your input is your exit and your output is your price. If the person wants to know what the price is for kilometer 15, he will just refer to the table and look for 15 and match it with the corresponding price. So we know that for kilometer 15, it's 30 pesos. There's also another way of looking at a function. They can be interpreted as graphs. What are common graphs? For example, we have rainfall. So throughout the year, you have January, February, March, and so on, up to November and December. If you chart rainfall, they can be in the form of bar graphs. Matched with corresponding rainfall readings, with this crude graph, we can say that the input are the months and the output is the level of rainfall. So we say, look at the month of January, the rainfall is just 10. For the month of February, the rainfall is just 20. They may appear so simple, but these are already examples of functions. So functions are different from equations, such that functions give you unique values for your outputs. Equations are anything that involves an equal sign.